Have here. This is Maths 209 and we are treating solutions to transcendental function. The solutions to transcendental function. And meanwhile, if we can recall, I said there are several ways to solve transcendental functions. I said number one, you can use the fixed point method. I said number two, you can use the what? The bisection method. I said number three, you can use the Newton-Raphson's method. I said number four, you can also as well use what we call the Aitken's method. Number five, you can use what we call the regular Fauci's method. Now, all these methods have their own peculiarity. So today we are treating the fixed point method. And what are the key notes for us to observe in the key fixed point method? Number one is that what? We must be able to find the interval of operation of the equation. Number one, we must be able to find the interval of operation of the equation. Number two, we must be able to derive the subject of formula. And number three, we must be able to what? To differentiate the subject of that formula that we derived. Excellent. Without wasting much of our time, we will be looking at some of the questions that we have. This is a photo pass question, and it says, find the root of x to the power of 3 plus x minus 1 is equal to 0 by fixed point iteration method, given that the root lies near 1. So the fact that that root lies near 1 makes us to understand that the answer is close to 1. The answer to that question is close to 1. Alright, so the first step is to do what? To find the subject of formula from this equation, this particular equation. X to the power of 3 plus x minus 1. We want to find the what? The subject of formula of this equation. And so what do? We said, provided that you have x raised to the power 3 plus x minus 1 is equal to 0, you can as well say that x to the power of 3 is equal to 1 minus x. What did we do? We just did what? By arrow. We just moved these people to the other side. Is that clear? And so when you have x to the power of 3 is equal to 1 minus x, you can as well say that x is equal to 1 minus x raised to the power 1 over 3. What did you do? You took the what? The cube root of both sides. That will now be what we call subject of formula 1. Or you can call it equation 1. Number two, what else again can we derive as subject of formula for x again? We can decide to do what? We can decide to factorize. This factorization means x to the power of 3 plus x minus 1 is equal to 0. This means x to the power of x squared plus 1 is equal to 1. What did I do? I just simply moved the minus 1 to the other region. Is that clear now? So as from here, what do? You can divide both sides by x squared plus 1. So your x now will be 1 over what? X squared plus 1. This is another subject of formula 2. Is that clear now? So all these that we just did here are step 1. Step 1 is a case where we try to do what? We try to find the subject of formula. Now step 2 is we now try to differentiate each subject of formula. Subject of formula 1, subject of formula 2. We try to differentiate it. And so we began to remind ourselves of chain rule when you were in 100 level. So we want to differentiate this particular one that says 1 minus x raised to the power of 1 raised to the power 1 over 3. Let me repeat that. 1 minus x to the power of 1 over 3. So let's differentiate that. We said let y equals to 1 minus x raised to the power of 1 over 3. Then 1 minus x is equal to p. You can see it here. Now y is equal to, let's represent 1 minus x as p and then bring them back to this equation. It means that what? Y is equal to p raised to the power 1 over 3. Is that correct? So that we can do a chain rule. This is the chain rule. dy dp should multiply dp dx. At the end of the day, you're going to have this as an answer. Negative 1 over 3 into the bracket of 1 minus x raised to the power minus 2 over 3. So if that's the case, then we can now differentiate the other one. We differentiate the second subject of formula, which is this 1 over x squared plus 1. If we take that same routine step, we're going to have this, right? So let me rewrite subject differential of, now the differential of s subject of formula 1 is minus 1 over 3 into bracket 1 minus x raised to the power minus 2 over 3, which is also known as what? Minus 1 over 3 into bracket 1 minus x raised to the power 2 over 3. Is that correct now? This is the differential of subject of formula 1. Then the differential of subject of formula 2 will now be minus 2 all over 1 plus x, right? 1 over x, that's a squared here, right? All squared to the power of 2. That's the differential of the second function. Now step 3. After you have differentiated each set of formula, step 3, we now test the interval of operation. We test the interval of operation into any of the differential that you got. To see if it's less than 1. All right, so if we test that here, right, test the interval of operation. Now what interval of operation do we have? They said close to 1, so we assume that x naught is equal to 1. So let's plug that here. It means we have minus 2 all over 1 plus 1 squared raised to the power 2, and that will give us 1 over 2. So it's less than 1. Is that correct? So it's less than what? 1. So we are going with this differential of SOF2. So since the differential, so we have noticed that, okay, let me write that out. We noticed that what? That the differential of SOF2, right, gave us an answer less than 1. This is the Leibniz rule. According to what? The Leibniz rule. Less than 1. Alright? If we test that here, for example, if you test 1 here, you will get an answer that is what? That is greater than 1. You can decide to do that anytime you like. Replace 1 here. So this is 1 minus 1, which is 0. 0, right? In fact, you're going to get an invalid here. This is an invalid function here. Because you're going to be having something like minus 1 over 0. Yes, this is invalid. This is math 0. 1 minus 1 here is 0. 3 times 0, 0, 0. So minus 1 over 0. This is an undefined function. This is error, right? So we rather go with this person, right? Now that we have been able to find out that the differential of SOF2 gave us an answer less than 1 according to Leibniz, then we go for SOF2 itself, not the differential, SOF2 itself. And so from there we said x1 is equal to 1 over, so what is SOF2? SOF2, subject of formula 2. Let's go and look at it. This is subject of formula 2. 1 over x squared plus 1. 1 over x squared plus 1. So that is 1 over 1 plus what? x squared plus 1 is the same thing as 1 plus x squared. So you can say 1 plus x squared. So we are saying x naught. We're starting from x naught, right? Which is the same thing as 1 over 1 plus 1 all squared, which is 0.5. And then x2. So whatever we get here is our x1, right? So 1 over 1 plus x1 squared, which is 1 over 1 plus 0.5 all squared, which is going to give us 0.8. If you do x3, that's 1 over 1 plus x2 all squared, which is 1 over 1 plus 0.8 all squared, which is what? 0.61. So therefore, by fixed point method, the root of the equation at the third iteration, because I stopped at x3, did you see that? At the third iteration is what? Is 0.61. So in your test and exam, they can decide to tell you that what? Stop at the 6th iteration, that's stop at x6. They can decide to tell you that stop at the 7th iteration, that's x7. They can decide to tell you that stop at the 8th iteration, that's x8. They can decide to tell you that stop at 9th iteration, that's x9. We must not forget. So the root of the equation is 0.61 using what? Fixed point method. Fixed point method.